This is Darb Dabney again, helping you to see some of the controls in action on the Unity 3D data viewer. It's an environment to import GIS 3D data and navigate it through gaming engine interface. This particular example is brought to you by data from Marin Map, County of Marin, California. And the particular area here is along Corte Madera Creek. The towns are Larkspur, Kentfield, San Rafael. And the very starting point is right outside a place in Green Bay called the MV Code Club. And it's here in the backside of this shopping mall. What you're looking at here is an ellipsoid that has front side in black, the back side in white, and it's colored in the same traditional color scheme used by seismic beach balls. The area in the photo has been imaged by aerial photography produced in an orthophoto sense, where the location's been corrected horizontally. Everything's to scale, and at the same time, if we look carefully, it's a 3D model. It's been draped over a terrain that's in a resolution of about 1 elevation point per square meter. So the controls are numerous. There are traditional gaming style AWSD keys that can be used, or the arrow keys, to move the focus point towards the camera. It's the down arrow, up arrow goes forward. Combinations will move the focus point around. And in this particular case, without any modifier keys, as the focus point turns, the camera will be following it in a turning angle. So as the focus point moves towards the right, we're essentially following along behind it with a little bit of twist in the focus point, just to provide a sense of turning. If this isn't moving fast enough, you can hold down the tab key, accelerate things about 3x, and move around a little bit faster. The focus point is kinematic, that is, it's not really colliding with the terrain surface, so you'll see it dive in once in a while. And there's page up and page down that can be used, of course, at the same time as the different directional keys, and essentially makes the thing move around like a little blimp. But by and large, the idea is this is a focus point, basically helping people visualize where the camera is looking. For people who are a little more anxious to get where they're going, there are option keys supported with a mouse click and drag. If I hold down the Alt key, here the cursor turns into a magnifying glass. Hold down the Alt and Control, the cursor turns into a little square with something that hints at making an orbit. And if you actually hold down Alt, Control, and Shift, then you get something that will allow you to do what's cinematically called a truck and pedestal. Truck means move sideways, pedestal means move up and down. And this is all happening in a plane, basically perpendicular to where the focus point is pointed. By itself, the orbit gives people a chance to first click to place the focus on some place of interest. Here I'll move off to the side, put it in the middle of this what's actually a tall building, and the orbit allows us to change, if you will, the latitude and longitude by moving up and down in latitude, all the way around in longitude, and orbit around, but you'll notice it's always at a fixed distance. By itself, just the Alt key will also let us change the longitude. At a fixed latitude, we can zoom in and out and change essentially the radius to the focus point, from way far back to quickly very close in. you'll notice that as we move around, essentially panning around behind it, the focus point stays looking at us. So the key thing is, if you've got Alt or Control key held down and you click with a mouse, you will be moved very close to the place that touches the first piece of terrain or the first object. For example, we've got some tall buildings imported from San Francisco, and as you can see, the focus point touches the outside of them. All right, that's kind of the whole idea. The point that makes this different than, say, desktop like ArcGIS Pro is that we've kept the same adjustment keys. Like if you do an alternate click, you will get the tumbling motion. If you click the scroll wheel as a button, you'll get the orbit motion. And those are basically borrowed from the ArcGIS or even from Roblox gaming things. But if you hold down an Alt key and click on an object, even if it's far away, you're there very fast. And once you get used to this kind of interface, particularly if you can point sideways and basically work your way around within a small space, it's much more versatile than the to click and turn, or click and dolly over, if you are, or rather truck over. It's faster than just using perhaps the orbits that you'll see frequently with Google Earth, or the this kind of trucking and pedestal type motion. Right? That's largely it. The purpose of putting this into a gaming engine is that the GIS data that's fit into here is pretty readily imported. We're able to get the terrain in. We're able to get 3D buildings with real-world textures, as you can see in. Everything's brought in to scale. This particular model was built at 1/10.24 scale, but everything that you see is kept accurate to the orthophoto. The terrain's been scaled without vertical exaggeration, and the two buildings that were borrowed from San Francisco are maintained in their original orientations. It's 600 Montgomery here and 50 Fremont over here. So the proof of this is that if you have a complete set of textured 3D buildings, obviously you can import them into Unity. You can import the terrain and drape the orthophoto over the terrain at fairly full resolution. The terrain was downgraded slightly to integer decimeters, and the orthophoto was downgraded slightly to 20 centimeter pixels for natural color and a JPEG compression. But those are moderate compromises. As you can see, you still get the pretty detailed sense of both the photo and the terrain, and of course, very importantly, they're accurate and to scale. So with that, the real way of reaching out to more users with this kind of approach is that thanks to the Unity engine, we can export essentially this game in a way that's consumable in a PC environment, Mac OS environment, an iOS environment, Android, Xbox, PS4, and Samsung TV, as well as, of course, a HTML5 WebGL format. So I've got some examples put up of how that looks, but by and large, it's just a demonstration. The development work has been to create the camera, the focus, and the next step of the development is to create an avatar character that will basically act in many ways like what you see the focus doing here. The avatar will be a humanoid that'll provide a sense of scale and give people a chance to interact with the 3D data in a a more personal way. Anyway, thanks very much for watching. This is, again, Darb Dabney providing a look at a Unity gaming engine designed to implement the Second Life interface, basically for purposes of serious gaming, GIS data, and real-world simulation. Thank you.